So today we shall be considering maximum power transfer. Well, in some practical situation, it's often required to obtain maximum power across a load. And so, for a circuit of known resistance, it's given that if you want a maximum power to an external load, then the load resistance must be the same as the internal resistance of that circuit. Okay, now the Thevenin equivalent circuit is useful in obtaining maximum power transfer. That's because it can present a circuit having the source and the resistance, which we can now assume to be the internal resistance. Well, as we proceed, I would explain. We know that the Thevenin equivalent circuit is always given like this with your VTH and your RTH. This is the Thevenin equivalent circuit. So it is the source VTH and this is the Thevenin resistance. Now we can now say that this Thevenin resistance is not treated as the internal resistance of the circuit. Then maximum power will occur when the load resistor load is same as the Thevenin resistance. Please understand that you must have done Thevenin theorem before doing maximum power because we are using Thevenin here. So you must have a knowledge of Thevenin, or you can go and watch our video on Thevenin to comprehend the maximum power. But I'm trying to say that maximum power will occur when the Thevenin resistance is same as your load. So that's that. So we can adjust the load to be same value as a Thevenin resistance. And this Thevenin resistance is treated as internal resistance of the circuit. So that's that about that. So this is the maximum power transfer theorem. Now it states that the maximum power will be supplied from a source to a load when the Thevenin resistance. So this is the maximum power theorem. So now let's derive the equation for maximum power. We know power is I square R. So I, the current to the load, times square of that current times the resistance of the load. Well, from our Thevenin theorem, we have it that the load current is given as your VTH over RTH plus RL. So if I replace my I with this, I will have my I now being this square times RL. Remember now that RTH and RL are the same if we must have maximum power. So I change every of my RL to RTH and RTH here. And that brings us to this place now. And then remember this will be 2RTH. And then if you square that, that will give us VTH plus the 2 will become 4 and the RTH will become squared times the RTH here. This eliminates one of the RTH and we're left with V square of VTH over 4RTH. This is the formula for maximum power. So that's that about that. Let's take an example now. In the circuit below, find the value of RL necessary for maximum power transfer. Find the value of the maximum power also. So let's solve that question now. So we'll go get our VTH and then also our RTH. So to get our VTH now, the first thing we're going to do here is to remove the load. So, and we do that by short circuiting the path. Sorry, open circuiting, not short circuiting. So we're looking for the open source voltage, which is our open circuit voltage, which is our VTH. 3 ohms, 3 ohms, 1 ohm, and 2 ohm. Then 15 volts. Now, understand that since this part is in parallel with this part, the voltage across the 3 ohm resistor is the voltage across the VTH. Well, we can simply use our voltage divider rule to get that here. So VTH, which is voltage across the 3 ohm resistor, because voltage in parallel are the same, will be 3 over 3 plus 3 times the source voltage 15. 3 over 6 times 15. That's 45 over 6. 15 over 2, 7.5 volts. That's my VTH. Now let's get our RTH now. We remove all voltage sources. Okay. Okay, so I often assume that to get my RTH now, I often assume that current comes from the open part. When the current gets here to split, so this 3 ohm in parallel with 3 ohms. 3 ohms in parallel with 3 ohms. And that will give us, the total resistance of these two will give us 3 times 3 over 3 plus 3. And that will give us 9 over 6, 3 over 2, 1.5 ohm. And then we go further, I could reduce this circuit. It then looks like this. Okay, so we have now 1.5 ohms, 2 ohms, and then the 1 ohm. And we're still looking for the RTH. So this is a series circuit, but when current comes from here, it goes through this part alone. So our RTH is simply going to be 1.5 plus 2 and then plus 1. That will give us 4.5 ohm. So we've gotten our RTH now. The next thing now to do is to get the, okay, first of all, we are looking for the value of RL. Well, I'm answering that first question. For maximum power now, we have it that RL is same as the RTH, which is 4.5 ohms. I've answered that now. Now, the B is the value of the maximum power. Well, P max is simply going to be VTH squared over 4 RL, and that will be VTH is giving us 7.5 square over 4 times the RTH, RTH, and that's 4.5. So let's calculate this now. So 7.5 square divided by 4 times 4.5, 3.125, 3.125 watts. So that's that about. Example 2, calculate the value of RL in the circuit below, which would be necessary for maximum power transfer. Find also the maximum power supplied by the circuit. Okay? The first thing here is to get the VTH, or to get your RL first, and whichever one. Let's get our VTH. Okay, so I'm looking for the voltage across this. Well, it's to get the current first. Let's call it I1. I'm using mesh. Let's call it I2. So this will give us 5 minus 3I1 minus 14 into I1 minus I2, which is equal to 0. This will give us 5 minus 3I1 minus 14I1 plus 14I2 equals 0. So this will give us 5 is equal to 17I1 minus 14I2. Equation 1. Well, this is for mesh 1. For the first mesh. For the second, we have minus 14 into I2 minus I1 minus 5I1 I2 minus 9I2 equal to 0. Minus 14I2 minus plus 14I1 minus 5I2 minus 9I2 equal to 0. So this will give us 14I1 minus 28I2 being equal to 0. This is equation 2. Simultaneously solving equation 1 and equation 2. We get that I1, if you solve this simultaneously, you get I1 is equal to 0.5 ampere and I2 will equal to 0.25 amperes. So understand that VTH is the voltage across the 9 ohm. And what current is flowing through this 9 ohm resistor? That's the I2, which is 0.25. So I can say VTH now, which is voltage across the 9 ohm resistor. And that's equal to the current 0.25 times 9. This will give us 2.25 volts. So we are done getting our VTH. Let's get our RTH because that's the value of our RL. To get RTH now, we will deactivate the voltage source. Okay. So let's calculate this. I'm not going to go straight direct. That's taking much time. First of all, 3 ohms in parallel with 14 ohms. And this combination in series with 5 ohm resistor. And that in parallel again with the 9 ohm resistor. Let's begin with this. This is 3 times 14 over 3 plus 14 plus 5, which should be in parallel with the 9 ohm resistor. So let's go with this now. That's 3 times 14 over 3 plus 14, 2.47. So 2.47 plus 5 in parallel with 9 ohm. And that will be 7.47 in parallel with 9 ohm. And that will give you total. This is my RTH. That will give us 7.47 times 9 over 7.47 plus 9. .08 ohms. So we can now say that RL, which is the first part of this question, RL is same as your RTH, which is 4.08 ohms. So we are done with getting our RL that will give us maximum power. Then we can calculate the maximum power now. So from our formula, P max is VTH square over 4RL. And that would be VTH is given as 2.25 squared over 4 multiplied by 4.08. 2.25 squared divided by 4 times 4.08, 0.31 ampere watts. That's that about this question.